The linear Diophantine equations are so useful even nowadays, and it was developed by that mathematician. But in the old time, they just do it by hand, and it kind of requires a lot of calculation and work. Uh, we have very powerful tools which we covered in the previous chapter, like the extended Euclidean algorithm, and it gives us much faster and simpler procedures to get the solutions, right? So we already have nice developed tools to approach and to solve those questions, right? So please just read. Of course, for every chapter in this lecture note, I'm not reading the textbook for you guys, right? So please reading assignments by yourself, and please also read those stuffs, right, in this study book, right? Uh, but and I just only focusing on those kind of calculation parts, right? So the linear differential equation is defined like the form must look like ax plus by equals 0. As a linear, there are some other stuff, so nonlinear cases, but in our course, we are going to focusing on those cases, right? And ABC is integer cases only. And if A is zeros at the same time, then 0 equals something, then C must be also 0. So it's kind of trivial, right? There is nothing we can talk about, right? So whenever we have those formats, at least A or B must be non-zero cases. But right, it's clear. And we are looking for the integer solutions for x and y only, right? That's the linear Diophantine equation. Now the question is, how can you solve it? What is going to be the solution? Actually, there are general formats of solutions, and that's the big main theorem about it. So whenever you're talking about linear Diophantine equations, let's say for given those coefficient a and b, we can calculate the greatest common divisor of a and b. And at this moment, A and B could be negative and positives. Doesn't matter, right? Not just zero at the same time, right? So please remember that. But greatest common divisor of A and B should be the greatest one, so it should be positive, right? Always. And you can always find such thing. So even it could be 1, but still you can do that. So with that given condition, whenever we have some cases we don't have any solution, of course, but if that equation has a solution, if and only if that greatest common divisor of a and b should be factor of that constant term c, okay? And vice versa. So let's just prove that fact first, right? Because it's if and only if we have to prove two theorems, right, in each direction. Let's remember that. So let's say for that given ax plus by equals c equation, let's say d is the greatest common divisor of a and b, which means d is a divisor of a and d is a divisor of b, right? That means there are two integers r and s, okay, satisfying a equals d times r and b equals d times s, okay, by the definition of divisor. Okay, then let's prove that direction, which means, let's say we have a solution for that, right? That's the statement. Okay? That's the condition right now. So this equation has a solution. Then let's say that xy are the solution of that case, right? So right now, temporarily, xy is some fixed number. Okay, so it's better to say x0, y0. Okay, so x0, y0 is the solution of that expression, which means ax0 plus by0 equals c. That's good. Then we can change that c equals ax0 by0 to, instead of a, we can put dr, right? And instead of b, we can put ds. And both terms has d as a common factor, so let's factor out d. Then these remaining ones, that are x0 plus sy0, is a combination of integers, right? x0, y0 is also integers, and r and s is also integers, right? So it looks like d times one integer equals c. then by the definition of it, D is a divisor of C, or factor of it, right? So that's the proof for that. Then let's go back, the converse of it. So right now, we don't know whether the given expression has a solution or not. All we need is when we calculate the greatest common divisor of A and B, that is also divisor of C. Okay? Which means there must be a constant t, which is an integer, satisfying d times t equals c by the definition of divisor. Okay? Now, our assumption was d is the greatest common divisor of a and b. Then, do you remember in the previous chapters, we found out that any greatest common divisor of two integers can be written by linear combination of those two numbers. Remember, right? We have that theorem before. So we know there are certain x0, y0 satisfying d equals this. Now be careful. We need to show ax plus by equals c has a solution, right? So it's not done yet. We know just by the previous theorem the that greatest common divisor of a and b should have linear combination of a and b. So meaning is there is a solution for x0, y0 combined with a and b and denotes d as an expression. Okay, then our assumption was c is just a multiple of d, right? So let's multiply t on both sides of this expression, right? So dt, the left-hand side becomes dt, which is same as c, the assumption, equals that expression times t. Then, after multiply t on both terms, you just bring out a and b from each of these. Then that expression looks like exactly ax plus by, when x equals t times x0 and y equals t times y0. So meaning is, yes, we have a solution because these are also integers, right? So we have a solution for this one by that. So that's the end of proof, the big thing, okay, the main thing. But we could go further because that solution is not unique. There are actually infinite many different solutions if there is a solution. Okay? So the next statement says, if xy is any particular solution, okay, like you can imagine like x0, y0 that we found over here, or it's not x0, y0, actually t times x0, y0, or t times y0, right? So anyway, whenever we have such solution, then there are many different solutions are possible, and they are given by this. So this xy is the solution value, right? So it's known, right? And b, we know that number, a, we know that, and d is the greatest common divisor of those. So the only unknown notation is t, and t is for any integer, which means, without proof, if we just put t equals 0 for both, then x prime is x plus b over d times 0, which is x, right? And y prime is y plus, actually minus a over d times 0, which is y. So this, the first solution that we found is actually the special case of these general forms when t equals 0 case, right? So this is the more general kind of solution for any linear Diophantine equation. But we cannot apply anytime because it's only when we have a solution, right? In some cases we don't have. So how do you know? Try to divide that constant term by that greatest common divisor of a and b. If you can do that, we have a solution. Then general solution form looks like this way, right? So please remember that word. So the remaining part is just proving why this one becomes the general solutions for that linear Diophant equations. So let's look at here. Let's say x, y is the solution of that, the first solution we found. Okay? And just assuming x prime, y prime is another solution, which means when you substitute x prime, y prime for x and y, we still get c, right? So we have that equations. So let's just subtract this right hand side on both sides, right? So left hand side, if you factor out common factor a, then a times x prime minus x, actually you subtract left hand side on both sides, right? And equals b times y minus y prime. Okay? So it's like this, from ax plus by equals ax prime plus by prime, and subtract these left hand side ones on both sides. Then left hand side becomes a 0, right? And right hand side we have ax prime minus ax plus by prime minus by, right? Then from here we have ax prime x plus by prime y, right? That's how we got this one. But what was a is a multiple of d, because d is a greatest common divisor, so there must be r. Okay, so instead of a we can put is a multiple of d, so just for some integer r we can change the formulas like this way. By the same reason, this portion changed to d times s y prime minus y. Now let's just move this one to the other hand side, right? So we need to get y minus y prime instead of y prime minus y, because we need to put negative in front of it, right? That's how you got this equality. Okay, from the beginning, we got everything. And both sides has d, so we can just cancel out and remaining that. Then when you look at it, just look at this one as a one integer, and that integer is r times another integer, which means r is a factor of this number, right? Or divisor of that number. Now, d was the greatest common divisor of a and b, and a and b is written that way. So if you remove d from those numbers, which means what? Remaining only r and s, we don't have any more common factor between these, because d is only the greatest common divisor. It's a collection of all possible cases, right? So leftover is always 1 for the greatest common divisor of them, right? So meaning is these r and s are relatively prime each other, right? Okay, then from that point of view, we know that r and s are not divisor of each other, right? There is no even common factors between these. So at this moment, we have r is a factor of s times certain number, right? This is s, right? And we know r and s, there is no common factor whatsoever. They are relatively prime, which means since r is a factor of these two, multiple of this number, which means r must be a divisor of the remaining portion of it, right? So from here, we got r is a divisor of y minus y prime, which means there must be some integer t is multiplied to r makes that number, right? By the definition of divisor. So let's change this r times x prime minus x, which is over here. Then it's, instead of r, we can put the srt, right? Because the right hand side is s times y minus y prime, right? So y minus y prime is rt, so s times rt, right? So from that equation, we got r times x prime minus x equals s times rt. Like that. But both sides has r, so after cancel out those r, we have x prime minus x equals st. So from here, we have a notation for x prime. Once again, when we started, we already knew what the values for x and y, because our assumption is we already found the solution for that, right? So x, y is a known numbers, right? But we just saying, okay, let's say there is a x prime, y prime as another solution, which we didn't know about that. But now finally we have the value for that, right? X prime can be written from here, can be written by x plus st, all known numbers by that calculation. And s was too many scratches. Okay, so when we think B was D times S, right? So from here, S must be B over D. So instead of S, we just put B over D. And from this one, we got that expression. So Y prime is Y minus RT, and that R can be changed to A minus D, right? So look at this case. X has plus, then Y has minus. Okay, remember that. So altogether, after we found x prime and y prime, let's look at this expression. Ax prime plus by prime. Then, by the calculation, we are going to get C, which means what? X prime, y prime is another solution for that expression, ax plus by equals C. So meaning is, this becomes another solution. But now, in this case, what was t? It is just some integer. We didn't put any condition for t. The only condition for t is just the integer, which means t could be 0, 1, 2, 3, and even negative 1, negative, negative 3, right? So the entire integer could be that t. So which means what we just found is not only just another solution, but is a list of infinitely many different solutions. All we need is just to plug, substitute any integer for t, it will returns different solutions at each time. Okay? And we already checked what happens when t equals 0, that returns the original solutions we found. Okay, so that's the entire proof for that. But for the actual calculation, because if you follow that rules every time, it really takes a long time to do it, right? So we need to use that extended Euclidean algorithm, okay? So from now on, whenever this question saying solve the given expression or equation, and when you figure out, oh, this is linear Diophantine equation, like because it looks like ax plus by equals c star, okay? Then the first thing you have to check, listen carefully, is whether we have solution or not. Remember, the linear Diophantine equation has a solution only if satisfying certain condition. What was it? Let's say D is the greatest common divisor of A and B, then only if that greatest common divisor of A and B is a divisor of C. Okay? So we need to check that condition first. So first thing is what? We need to check what is the greatest common divisor of those two numbers. By what? By Euclidean algorithm. But if it has the solution, then we need to find what? The linear combination of A and B to get D, right? Because greatest common divisor can be written by certain formats like this, right? Using A and B, right? Then how can you find those solutions? Remember that extended Euclidean algorithm, right? All together. So my suggestion is do it at once, right? No matter what the situation is. We need to find the D, right? Greatest common divisor. And if it is, then we have to find those x0, y0 to get all the solutions of it. So let's just do together. Okay? So do you remember what this extended Euclidean algorithm is? Remember? So let me just follow that rules here. So first one is 172 and divided by 20, right? Okay. And my solution was remainder, right? And quotient. And S and T was there, and 1001, right? So these are the same line like that. And we need S times quotient and T times quotient. Okay, so that's the whole setting. Okay, now please understand the situation. The reason that I'm using Excel file is I want to speed up, right? Okay. But in your case, you have to use that Excel file for just checking method, right? Or some kind of guidance or some hint, right? Don't just use it to get your answer, okay? You need to practice with your own hands, right? So please do this one, okay, on the paper, okay? So now the given, let me, okay, I need to do that first. Given number is 172 and 20. So it gives us like that, but in actual case, you have to do it one by one. So write down those 170 to 20 and 1001 and remainder quotient and quotient times S quotient times T. Okay. So next step, when you take the real division, the quotient is 8 and remainder is 12, right? Then please calculate those and you have to subtract, right? From one above line and subtract this one, write down one down line. Okay. So 1 minus 0 is 1, 0 minus 8 is negative 8. Next one, put down that divisor as a dividend and remainder as a divisor, right? Just push down, okay? One left down side and do the next division and doing all this stuff. So remainder is 8 and 1 times of those numbers are 1 and negative 8 again, and we have to subtract. So it becomes 0 minus 1 is negative 1, 1 minus negative 8 is 9. Okay? Then 12 and 8 again, so 4 and 1, so negative 1, 9, when you multiply like that, subtract 1, 1 minus negative 1 is 2, negative 8 minus 9 is negative 17. Now we hit 0 for remainder, which means what? 1 above, right? Or 1 left. Okay? So the last non-zero remainder should be the greatest common divisor of these two, right? We found it. But not only that, that 4, the greatest common divisor of those two numbers, can be written by the linear combination of these two given number and last results on these last two columns, right? And the positions are matching, okay? So 4 should be 172 times 2 plus that number times that number, right? So that's the reason most likely you are going to have altering plus minuses here, right? Okay. So these are 2 and negative 17 is for our A and B, right? Okay. Just be careful which one is which. So after you finish all of this, eventually we are going to get the greatest common divisor of 172.20 is 4, right? So we got D equals 4, and that 4 is 172 times 2 plus 20 times negative 17. So we found out those facts, but first thing first, right? Now we found the 4, so we need to check that 4 is a factor or divisor of that constant, right? And of course, right, 1000 is multiple of 4. It's clear, so it's yes. Which means what? That 172x plus 20y equals 1000 has infinitely many solutions, right? And how can you find those stuff? Let's just find out this way. Right now, so far, what we have is 172 times 2 plus 20 times negative 17 equals only 4. What we are looking for is 172 times x plus 20 times y equals 1000, right? So look at comparing these two. Then we found out we need to multiply certain value here to make 1000. Now you see the reason why this one is requirement, right? By multiplying certain integer, we need to make that one. If we cannot do that, we are not guaranteed that we have an integer solution for that, right? So this d should be a factor of 1000. Okay. Anyway, so how much do we need? Just 1000 divided by 4 is a 250, right? So we need to multiply 250 to that kind of x and y, okay? And 117 times 250, and we know it should be 1000. Then this must be x, and that must be y, or you can put x0, y0 for this, right? That's our first solution, right? So be careful. From this extended Euclidean algorithm, whatever you got this number, they are not the solution of the original expression, okay? These are only the numbers to get the greatest common divisor from the linear combination of those two. And if that constant is multiple of that greatest common divisor, then we can find our first solution by that. Okay? So from there, we know x0 must be 500, right? And y0 is negative 4250. Please calculate. So that's the first solution. So if they want just a solution, one solution, then the solution is 500 comma negative 4250 xy coordinate system. So that's enough. Or just to put this way, right? Either way. But most likely, if it's a linear Diophantine equation, they want all possible solutions, right? So therefore, from that theorem previously, the general solution is x0, remember, plus and one number over d, right? This is d, right? And t. So d is 4, we know that. But what is the numerator of that? It's the other ones, right? So right now we are talking about this, then we are talking about that number, right? So when you're talking about y, then we are talking about that number for its numerator. Okay? So it's going to be 20, and y must be negative 4250, and another thing, minus, right? This one is plus and that is minus. Minus 172 over 4t. Of course, don't forget to mention this t must be integer. Okay? Then another thing, 4 was the greatest common divisor of 170 and 2, which means these numbers should be integer, right? It's divisible by 4. So finally, the real answer must be this one, and y is negative 4250 minus 43t, right? And 4t is just arbitrary integers. So look at here. Just imagine we don't have that extended Euclidean algorithm. Then this procedure is going to take much longer than this. So this is kind of the simplest way to find that solution. Okay, let's just cover one more example. It says solve the linear differential equation again. Okay, so, okay, good. So please do by hands, okay? It's 7245, right? So, go to main and 72 and 45. Okay, 70 to 45. Okay, great. So we found that result. The greatest common divisor of these two numbers is 9, right? And the linear combination should be 2 and -3 for that. So after you do all that kind of tables, we are going to get the greatest common divisor of 72, 45 is 9. And that 9 can be written by 72 times 2 plus 45 times -3. Okay, good. But is that great common divisor 9 is a divisor of 24? It's not, right? So all you need is, since 9 is not a divisor of 24, the 72x plus 45y equals 24 does not have any solution, or if you want to empathize that, does not have any integer solution, right? If you're looking for some arbitrary real number solution, you can find it always, right? But if you're looking for integer solution, then it does, right? It does not have. Okay, so let's look at the, the example or the question from the all stuff, right? So this is one case like we found, okay, in the trace of the old stuff, but let's just kind of translate it, okay, in our word case. So it says a farmer purchased 100 head of livestock for a total of 4,848, and each cow sold for 145, and lamb sold for 60 for each, and piglets for 30, right? So how many of each type of this animal that the farmer actually bought, right? So that's the kind of question. So these are already given, so I don't want to spend time just to explain the whole thing. You can read it, but you can translate this word problem into some mathematical equation, right? So you need to assign some variables that we are looking for. Okay? How many each type? So let's say X is number of calves, Y is number of lambs, and Z is number of piglets, right? Then when it says the farmer wanted to buy 100 heads, right? So when you're adding these three numbers, it must be 100. And each one worth that much amount, right? So 145 times X plus 60 times Y plus 30 times Z should be total amount that farmer paid. Okay? But for this type of word problem, please remember this. There is always hidden domain because it's our real life situation, and whenever you need to count something or whatever, measuring some length, whatever, there is no negative. So be careful. Word problem, think what? Oh, it should be non-negative, right? Zero or positive cases only, right? So it's like this. So who says the farmer must buy at least one of each of these animals? So to matching this condition, maybe farmer didn't buy piglet. It's possible, right? So this x, y, z could be zero. But other than that, it should be positive integers, right? There's no way negative two piglets, right? Like that. So that's the hidden condition. So many question, look at the question itself. It doesn't say at all for that condition, but when you try to translate this English to Mathlish, you have to find those hidden domain for the variables, right? That's the one common kind of mistake for everybody did. So please empathize. I want to emphasize that, so please remember that. So from the first equation, how can you solve it? we have to try to reduce the variables, right? And looking for some x equals something, then it's easy to calculate, right? The only problem is before starting anything, because these two, we have two expressions uh, to get uh, the solution for three variables, which means it might be not a single unique solution, right? It might be infinitely many, but because of given hidden condition, we only could find finitely many, right? So please remember that, right? Because we have only two equations to calculate some some relation among three uh, different variables. Okay, but anyway, try to reduce the variables. So from the first one, we got that, and substitute to the other ones, and try to calculate it. So please do. So at the end, we found out this, right? After we remove z, we have only one equation left, and that is the like linear differential equation. Right? So use that extended method. It's a little bit different way to did it, right? So put st times no qs and qt right over here, right? So they just change the format, but same thing. So it turns out that greatest common divisor of those two coefficient is 6, and 6 is a divisor of 1848, which means yes, we have a solution. Okay, then, and from this one, we got those answers, right? Of course, right now, yeah, -1 cannot be the solution for x, right? But look at here, because it has a solution, there are infinitely many of them, and we have to drop out those cases later, so you have to accept it. Then from there, we can calculate what the general solution of it, right? So that's the formats of it. Then from this, we can also calculate what z should be, right? Now, the real power of that hidden condition is now here. Right? That xyz cannot be negative, which means that one should be greater than or equal to 0. So we found out t must be any integer greater than or equal to 61.6. Y should be also greater than or equal to 0, which means t should be less than or equal to 64 point something. And z is greater than or equal to 0, satisfying t must be greater than or equal to 58 something. So if you put those three conditions for t all together, then 62, 63, 64 are the only t values satisfying those non-negative values for x, y, z condition. And when you put this t for x, y, z, the general solutions of x, y, z here, then these are the corresponding x, y, z values. So we have three different cases to satisfying the given condition that farmer brought that animals, right? The first case is 2 doves, right? And 54 lambs and 44 piglets, or this one or that. And through the homework assignment, please enjoy this whole process.